okay, your presentation. So make sure you already completed the slide. Okay, maybe you are now in the preparing. Okay, maybe right now you are still preparing the slide. But you need to make sure the presentation is flawless because the carry mark is quite huge here. It's about 20%. So today we will try to cover the drawing section. Since the Monday class we don't have we cannot have the class. Okay, since I need to attend to somewhere else. Okay, I need to go to JB. I need to visit the factory. Okay, so that's why by hook or by crook we need to have this replacement class. So for that we can we can try to cover part of the drawing session. So before we proceed with the drawing session, I think it's good for us to recall back what you have learned in the pressing section. So in the pressing section, you need to remember the task of the paper machine in the pressing section. They have two major tasks. Okay, the first one is to distribute the fiber randomly into a uniform sheet, and then the second one is to remove the water as much as possible. Okay, the targeted moisture content after the processing process is about 35 to 50%, but usually they obtain about 40%. So it depends on the quality of the paper and the secondary fiber. So this is a very good graphic to show how the moisture or water is reduced, okay, according to different section in the paper making. Okay, from here we can see that pressing sections in the former section we remove a significant amount of water, and then same goes with the pressing section. This is because we need to remove as much water as possible because we need to save energy consumption in the drying section, because drying section is related to the evaporation process. So when we want to remove the water, okay, through evaporations, it requires energy. Okay, it requires a lot of energy. So instead of using evaporation technique, so it's good for us to remove the water mechanically. So that's why we have the press section. Okay, so there are two primary objectives of the press section. It is to remove water and then to consolidate the web. Okay, when they consolidate the web, it will allow good runnability in the drying section. Okay, and then the most important part in the drying section, you need to remember the four phases happen between the two rolls. Okay, what happened between the felt, what happened to the web, and then what kind of pressure involved. Okay, and then you need to be able to identify how the total pressure and hydraulic pressure changes from phase 1 to phase 4. Okay, so this is very important. So you need to remember and understand this one. This is a very important part in the pressing section. Okay, and then after pressing section, we will have the drying section. Okay, so today we will cover the drying section. One of the most important part in the paper making machine, okay, in the paper making industry. Okay, why it is one of the most important part? Because drying section is a section that removes the water until we reach the targeted moisture content for the paper, usually about 6 to 8%. So that's why before we move forward the paper web or the sheet to the drying section, we must remove the water as much as possible, okay, by mechanical action. That's why we have the pressing section and also the forming section. Okay, after we remove the water as much as possible, the drying section is the last stage, okay, for you to remove the water. Not the calendaring, not the reeling, not the finishing. Okay, so alahai, selambatnya lah korang ni masuk. Okay, the drying section. So for the introduction, sometimes students neglect to read the introductions. Introduction is very important because it will introduce you about certain theory or certain knowledge or certain information or anything related to the topic that you want to study. So introduction is very important. Okay, without introduction, the student or maybe the lecturer is lecturers like me, it's very difficult for me to understand what I'm trying to deliver, what I'm trying to understand. So you need to understand the introduction. So introduction is very important. So for the introduction in the drawing process, this is the introduction. Okay, after pressing the section, the web is conveyed through the drawing section. This is a continuous process. That's why we have the approach flow system. Okay, when you are talking about the approach flow system, all of these processes happen continuously. That's why the quality of the fiber from the beginning of the paper making, from the disintegration process, from the beating process, we need to control the quality of the paper, or else we cannot have an efficient approach flow system. Okay, maybe some of the sheet or web will be break along the process, so we need to stop the whole manufacturing. Okay, it will be very costly. So basically, paper making industries will lose a lot of revenues from this event. So in order for us to make sure that we can have a very good and continuous process, so we need to make sure the quality of the fiber and then the quality of the process. Okay, we need to control everything. So in order for us to control all of this quality and also to control this continuous process in the approach flow system, we need to understand what actually happened in every section. Okay, there are two objectives. Okay, there are two main objectives of the drawing. Okay, since this is drying, so the very first objective is to evaporate water as much as possible. Okay, in the pressing, we want to remove the water as much as possible and then to consolidate the web. Okay, why we can consolidate the web? Because we are pressing, we are talking about pressing, so we consolidate the web. So in the drying, same like in the pressing process. Okay, first they are removing the water through evaporation process using a minimum machine. Okay, machine should be designed to reduce energy usage. So the second one is to spreading the evaporation as evenly as possible. So these are two main objectives of the drying process. So evaporation in the cross direction, okay, in the cross direction of the machine is the most critical. Okay, so the machine, you have the machine direction and also the cross direction. So usually the cross direction is most difficult one. If there is a variation in the moisture at the end of the drying process, the quality of the sheet will be affected, such as creeping. Okay. So this is the 4 Dryner paper machine. So we have the flow spreader, head box, okay, 4 Dryner table, and then we have the press sections, and then we have a drying sections. Okay, press sections, when we compare to the drying section, the section is very huge, so it requires a lot of spaces, okay, compared to the press section. That's why in the press section, we need to efficiently remove the water, okay, up to until we get about 35 to 50%, usually about 40%. Wait, huh? Okay. So as the paper web leave the press section, okay, with the moisture content about 35 to 50%, okay, considerably more than half of its weight of is water. So the drying section received the web from the press section at the moisture content between 50 to 65, even though the targeted moisture content after the pressing is about 35 to 50%, but usually in the drying section, they will receive the paper sheet or paper web or sheet web, okay, the moisture content is within 50 to 65%, okay, but it depends on the quality of the fiber. It all depends on the quality of the secondary fiber and the virgin pulp. So here the remaining water in the web that cannot be removed by vacuum or pressing is removed by evaporation. That's why we need to remove as much water as possible in the pressing section. Okay, so this water must be removed in the drying section of the pepper machine to the level between 6 and 8%. Okay, from 50 to 65. So we need to remove the moisture content, and then the targeted moisture content of the pepper is about 6 to 8%. Okay, before the pepper can be suitably used. Okay, usually the pepper that you have, that you hold, the moisture content is about 6 to 8%, depending on the relative humidity. Okay, so the removal of water by use of steam. Okay, the removal of water by use of steam, heated cylinder. Okay, they are using heated cylinder in the drying section. Okay, they are not using an oven, so it will be impossible for us to dry the pepper web in a continuous process by using an oven. So up until now, the most efficient way to remove the water via evaporation, they are using the steam heated cylinder. In spite of high capital investment and running costs, it is still the best and efficient process. So drying section is the most expensive part of the pepper making operation, the most expensive part. That's why we need to remove the water, okay? About 60% of the pepper mill energy requirement. Okay, almost equivalent to the total moisture content in the web. Okay, so if we can reduce the water during the pressing and forming as much as possible, basically we can reduce energy consumption in the drying process. But you need to remember, even though in the pressing section we want to remove the water as much as possible, but we cannot totally remove the water. Okay, if we totally remove the water, the quality of the web will be very low. Okay, you need to understand in the present section. Okay, so about 60% of the pepper mill energy requirement and 80% of the heat requirement. So other than water removal, fiber to fiber bonding happens at the drying section. As we remove the water, there is a capillary force and surface tension happen, okay, within the fiber or intrafiber, okay, interfiber or intrafiber. That's why we have the inter-hydrogen bonding and we have the intra-hydrogen bonding, or we call them as the interfiber bonding and intrafiber bonding. So during the drying section, we will have the fiber to fiber bonding. Okay, you need to remember fiber to fiber could be intrafiber or interfiber. So forming of hydrogen bond is due to the capillary force or surface tension. Basically, with the surface tension, when the surface tension of the water happen, as the water is reduced, the surface tension will be increased. So that's why we will have the capillary force. So the ability of a liquid to flow in narrow spaces without the assistance of or even in opposition to external forces like gravity. So for hydrogen bonding to take place, it is necessary that the distance between the facing surfaces are within about 0.27 nanometer. Okay, so the initial wet web strength, okay, the initial wet web strength, after we remove the moisture in the pressing section, basically the solid content is what? It's about more than 40%. So the initial wet web strength is about, solid content is about less than 40% in a consequence of the possible mechanical entanglement of the fiber and the onset of surface tension forces as. Okay, don't worry about this part. Later on, I will explain what actually happened in the mechanical entanglement and the onset of the surface tension, how they can affect the quality of the strength. We are talking about the hydrogen bonding, intra and interfiber bonding of the fiber. Okay, so this is what we call about the interfiber bonds in pepper form gradually as solid content increases. So Okay, please refer to A, entanglement friction. So entanglement friction, we are talking about the friction between the fiber. Okay, but the entanglement friction of between the fiber, the wet web strength just increase a very diminutive increase when we compare to B, the hydrogen bonding. Okay, so when you are referring to the hydrogen bonding, so as we remove more water, okay, through the drying process, okay, after the pressing, the moisture content is about 40%, and then we reduce. Okay, no, the moisture content is about 60%. So that's why the solid content is about 40%. So after we remove the water, so basically the solid content will be increased as the water, as the amount of water is reduced via evaporation process. So when we remove the water, as you can see on the left picture, so we have the fiber wall and then we have the lumen. So, and then we have the liquid bridge. So the liquid bridge, okay, as we remove the water, so the water will be reduced, the amount of water will be reduced. So the surface tension action will be increased. Okay, the surface tension will be increased. When the surface tension is increased because of the reduction of water, so basically the fiber wall structure will collapse. Actually, not collapse. Basically, they are becoming closer to one another because there is a formation of the interfiber bonds. This is what we call interfiber bonds. Okay. And then when we add sum together between A and B, so basically the wet web strengths increase proportionally with the reductions of the water and then with the increment of the solid content. Okay, so this is how the entanglement frictions and hydrogen bonding affected the quality of the pepper. Okay, when we are talking about the quality of the pepper, we are talking about the wet web strengths, okay, where the wet web strengths is driven by the interfiber bonds and also the intra-fiber bonds. So this is what we call the intra-fiber bonding, okay? Role of surface tension, so this is the water between fibers. So when we remove the water, so basically there is an increment in the surface tension. So when and then at the same time, surface tension within the lumen of the fiber. So basically, this is what happened between the fiber. So there is a formation of the hydrogen bonding. So at the same time, the wet web strength will be increased with the increase of the solid content, with and also with the decrease of water in the wet web. Okay. So the sheet is dried by wrapping, which include passing the sheet through a series of rotating steam heat cylinders. Okay, as you can see on the figures that we provide here in this slide, okay, there is a cylinder. This cylinder structure is quite huge. Okay, the diameter is within 1.5 to 2.2 meter in diameter. Okay, so since we are talking about the continuous process in the approach flow system, so this evaporation process of heating process happen in rotational event. Okay, so we are using the rotating steam heated cylinders where the diameters is about 1.5 to 2.2 meter. Okay, it could be bigger than that depending on the capacity of the pepper manufacturing. So a permeable fabric or dry felts, okay, you need to know, you need to remember, other than the wet web, okay, of the sheet of the fiber, okay, there are another things that comes together. Same with in the pressing process, we have the felt. Okay, the dry felt holds the web firmly against the hot surface. Okay, the hot surface. So the felt also helps control the cross direction shrinkage and flatten the web. So when you are talking about the drying section in the pepper making, so basically the main machine, okay, the main machinery involved in the drying process is the rotating steam heated cylinders. Okay, up until now, this is the most efficient way for us to remove water in the sheet, okay, in the wet web sheet. So normally, the dryer consists of single tier cylinders. Okay, it consists either single tier cylinders, or we call them as a single felted with suction, and two tier cylinders. Okay, okay, and not all. So two tier cylinders, single or double felted. Okay, for the single tier, it could usually single, but for the two tier, it could be single or double felted. So modern paper machine, okay, modern paper machine usually has about 3 to 5 dryer sections. But in each dryer section, they contains of about 6 to 16 drying cylinders. Okay, let's say this is the first drying section. So when we count this is the drying cylinders. So in each section, okay, they contains of about 6 to 16. Okay, 6 to 16 drying cylinders. So can you imagine how big is the drying section in the paper making? Okay, let's say they have 5 drying section. Each of the section, they have about 16 drying cylinders. Can you imagine how huge the drying sections consume the space? Okay, so you need to remember each section has 6 to 16 drying cylinders with independent steam pressure may be the same or different felt group. Okay, single tier system at least being used on the first section of the drying process. Okay, usually in the very first section in drying process, they will use a single tier, okay, or single felted with suction. However, this system has become more popular. So this is what we call a single tier cylinder, okay, and then with the single felt. Okay, that one we have the sheet or the wet web, and then come together with the felt. Okay, felt is used to press the sheet to come closer, okay, to have a very good contact with the cylinder. For that, the sheet can have an efficient evaporation process. Without felt, basically, it will be impossible for us to totally dry the sheet. So we require felt in this system. And then this is a single dryer configuration, but it is very seldom for a paper making manufacturer use solely single dryer configuration. Okay, usually they come together with the two tier cylinder. This is a two tier cylinder. We have part and the lower part. That's what we call them as a two tier cylinder. So in this picture, basically this one is a two tier cylinder. Okay. Okay, two tier cylinder with single thumb. Okay, as you can see, the dotted line referring to the thumb. Okay. And then this one, we have the two with double thumb. Okay, so it depends on the quality of the pepper that you want to produce. Either you want to make sure the pepper has a very uniform pepper surface, maybe you opt to use the two-tier cylinder with single felt. Or maybe you want to have a very efficient removal of water. Okay, you want to reduce the number of section in the drying section, maybe you can opt to use the two-tier cylinder double felted. Okay, so the drying section consumed the highest energy. Okay, the highest energy, about 60% of the total energy used in the paper making. So energy is the heat energy in the form of steam. Okay, so the dryers also uses the biggest space, like I mentioned before. Can you imagine each section contains of about 6 to 16 cylinders. The cylinders is very huge, 1.5 to 2.2 meter. Okay, so the dryer also uses the biggest space and it is the most in terms of capital cost. Drying ability depends on two factors. Okay, you need to remember the objective of the evenly. There are two main objectives of the drying. So the drying ability depends on two factors. Okay, first the evaporation rate. So high evaporation rate is desirable, but must be done within the constraint of the pepper grade. Okay, so it must be suitable for the grade of the pepper to dry when we want to dry the pepper. Okay, other than that, an even evaporation needed for the moisture content and cross direction. So high grammage, high grammage meaning to say the fiber dense. So if we remove the water at high drying rate, so basically there is uneven evaporation of the water happen. So that's why for high grammage paper, we need to have a very low drying rate. For low grammage paper, so we can have a very fast drying rate. So influenced by steam pressure used inside the drying cylinder. So this is the second objective of the drying. So we need to have an even evaporation. First, we need to evaporate the water as much as possible, and then we need to have an even evaporation. So this is the drying ability, depend on two factors. And then the second factors is the steam economy. When we are talking about the steam economy, we are referring to the energy used per evaporated water. Okay, so kilojoule per kilo. So low usage of steam is more economical. So that's why in the paper making, once they have grade A, for instance, okay, it could be anything. It could be the secondary fiber could come from the office, could come from the paper waste, or maybe most of the fiber used from maybe the portion has higher virgin pulp. So it depends on the quality of the fiber they manufacture. So when you are talking about the steam economy, so the steam economy, usually they will use a similar technology throughout the process. Since this is an approach flow system, we are talking about the continuous process. So they need to use the same quality of the fiber. It is actually it's impossible. Let's say day one, they want to use grade A. Day two, they want to use grade B. So they need to change all the parameters in the forming section, in the pressing section, in the drying sections. That's why before they proceed with the pepper making, they already identified the quality of the pepper. Only then they can have a very efficient continuous process. That's why knowledge is power, okay? So this is the cost of water removal. As you can see, drying section amounted of about 70, more than 60%, can up to 80% of the total cost in the paper making manufacturing. So the drying section is the most expensive in terms of capital cost, the most expensive part. That's why we need to remove the water as much as possible in the forming and also the pressing section. That's why that section only require a mechanical action compared to the drying section. They require more energy. We are talking about heat. So also the most costly to operate because of the high energy consumption. So hence, efforts are being carried out to increase evaporation rate, reduce number of dryer. Okay, since each they have about 3 to 6 dryers. Okay, sections. So each section contains about 6 to 16 cylinders. Can you imagine how much energy they use just to evaporate water? And then, hence, effort are being carried out to increase the evaporation rate and conserve the energy by reduce the steam usage. Okay, so now we move forward with the drying cycle. Okay, now we move forward with the drying cycle. So the multi-cylinder drying process consists of repeated cycles in the direction of web travel. Okay, so each cycle has different phases depending on the dryer configuration. Typically, they will have 4 phases. Okay, every phase has an individual heat and mass transfer mechanism, a specific evaporation rate, and a web temperature. So are the 4 phases of drying. As you can see, we have the number 1, 2, 3, and 4. Each of the cylinder has 4 phases. Okay, later on I will explain what happened to the web, what happened to the felts during the evaporation or during the drying process on each cylinder. Okay, so 4 phases of drying with conventional double tier configuration, 2-tier and double filtered. Okay, in the green circle here, We are referring to the phase 1. So the dotted line is referring to the paper web, okay? And then the straight line, okay, we are referring to the upper felts. Okay, without dots, we are referring to the upper felts. Okay, the sheet is in contact with the outer surface. Okay, as you can see, the paper web still in contact with the outer surface. Not yet has the upper felt is not yet has any contact with the paper web. Okay, right now in the phase 1, they have the outer surface contact with the outer surface of the cylinder, while its other side is exposed to air and evaporation is low. Okay, sorry, okay. So in contact with the outer surface of the cylinder, okay, this is the cylinder, they have the contact with the outer surface, and then at the same time, they don't have any contact with the felt. So that's why the exposed to air and evaporation is low in this phase. Why the evaporation is low? Because they just have the contact with the cylinder. So basically the temperature just about to increase. So the evaporation maybe not happen yet in the phase 1. And then we move forward to the phase 2. So the sheet remains in contact with the cylinder surface and is covered on its outer surface by the felt that apply pressure on the weld. Okay, that's why I said felt is very important because it will help the drying process to happen more efficient. Okay, to occur more efficiently. So that's why here in the phase 2, as you can see here, felt applies pressure on the web. So heat transfer is increased since they have higher contact to the cylinder, and then sheet temperature increase during this long phase, and most of the heat transfers occurs. Okay, and then we move forward to the phase 3. So again, phase 3 is almost identical to phase 1. But what makes them different is that at phase 3, the temperature of the web is already high compared to the phase 1. So the fabric comes away from the sheet, okay, which remains in contact with the cylinder. We are talking about fabric, we are talking about the felt. So evaporation occurs from the newly exposed surface of the sheet, not in contact with the cylinder. So during the phase 2, there is little or no evaporation. But at phase 2, the temperature is increased in order to have a very efficient drying process. Okay, in the phase 3, it's identical to phase 1, but at the phase 3, the web start to evaporate. Okay, we assume that the temperature is high enough to make sure that the water is removed from the web. So evaporation occurs from the newly exposed surface of the sheet, not in contact with the cylinder, only on the outer surface that has no contact with the felt. Okay, in this right side. Okay, and then we move forward to the phase 4 between the drying cylinder. So phase 4 is between the drying cylinder. Okay, so for the web to move from one cylinder to another cylinder, that's why in the pressing process, we need to make sure that we consolidate the web as much as possible, or else the paper web cannot go continuously from one cylinder to another cylinder in the drying process. So the sheet is no longer in contact with the cylinder and no longer contact with the felt, and is moving forward to the next cylinder. We are talking about the drying cylinder. So evaporation occurs from both sides of the sheet, resulting in decrease in sheet temperature. Okay, since there has no contact, okay, between these two cylinder, so basically there is no heating process happen, so the temperature is reduced. Even though the temperature is reduced, but the evaporation occurs from both sides of the sheet, resulting in basically there are more evaporation happen. Since the evaporation happens, they release the heat, and then that's why, and then at the same time there is no heating mechanism happen to the in the fourth phase. So that's why the temperature is decreased. So it is during this phase that the evaporation rate is highest. Okay, And then the whole cycle is repeated as the pepper enters phase 1 of the next drying cylinder. So these are the 4 phases that you need to understand. Okay, there is no evaporation happen in phase 1, phase 2. Okay, the evaporation only started to happen in phase 3. And then most evaporation happen in the phase 4 because both sides of the web is exposed to the air. So the water can evaporate more efficiently, but at the same time, the temperature will be decreased. Okay, very easy, right? So this is, we are talking about the evaporation zones. So during the drying process, web move through the drying cylinders. It passes through 4 distinct zones before exiting as a dry sheet. Okay, so during the process, web move through the drying cylinders. It passes through 4 distinct zones before exiting as a dry sheet. So 4 different evaporation zones. So we are talking about the warm-up zone. So this one is phase on what happened in each cylinders. So now we are talking about the evaporation zone. So the warm-up zones, we are talking about usually occurs during the first 5 cylinders. Okay, the first 5 drying cylinders. This is what the warm-up zone. And then we have the constant rate zone, the falling rate zone, and the bound water zone. Okay, all of this is related to the water. Okay, so this is the amount of water per, let's say we change the pound to kilo, so kilo of water per kilo of fiber. Okay, as we move forward from zone 1 to zone 4, basically the weight of water will be decreased. Okay, and then the weight of fiber will be increased. So the drying time, this is the drying time. So this is what happened to the zone 1, zone 2, zone 3, and zone 4. Okay, let's see what happened. So the warm-up zone, first 2 or 5 cylinders, usually 2 to 5, okay, usually we refer to 5 cylinders in the warm-up zones, serve to raise the temperature of sheet. Okay, so also called the heating phase. Warm-up, heating's the same, right? So the temperature of the web is about 38 to 82 degrees Celsius. Okay, this is the heating phase. So still, the amount of water is decreased compared to the weight of the fiber. As you can see in the heating phase, even though the heating phase, the temperature is not that high, but you need to consider that between 38 to 82 degrees Celsius, some of the water is evaporated, okay, from the well. Okay, and then we have the constant rate zone. This is where the removal of water is the highest. So where evaporation reaches a peak rate and maintained throughout as long as water is present on fiber surfaces or within the large capillaries. Okay, so we are talking about the capillaries or water present in the fiber surfaces. So this is where the evaporation reaches the highest. So you can see when the graph, okay, is more steep. Okay, so basically the evaporation rate is higher. So, and then we move forward to the next zone, the falling rate zone. Why we call them a falling rate zone? It is because after water is removed from the large capillaries, okay, and also on the surfaces of the fiber, it is left only in the small capillaries where amount of water is small. So hence, rate of evaporation is decreased. Okay, rate evaporation is referring to the steepness of the graph. Okay, as you can see, constant rate zone has the steepest graph. That's why they have the highest evaporation rate. And then when we move forward to the falling rate zone, basically the evaporation rate keep on decreasing, okay, before we reach to the bound water zone. So like I said, when we are talking about the zone, we are talking about the nature of the water and then what kind of water that we remove. Let's say, for instance, in the constant rate, we remove the water on the surface and also the capillary. So maybe some of the water exists in the capillary is not totally removed in the constant rate zone. So in the falling rate zone, they will remove the remaining water in the capillaries. So that's why the rate of evaporation is decreases. And then we have the bound water zone. So you have learned in the water, in the fiber, in the wood, actually, they have the free water and also bound water. So same goes in the pepper technology. We are talking about fiber, we are talking about two types of water. Okay, basically from the warm-up zone to the constant rate zone and also the falling rate zone, we are removing the free water that existed on the surface of the fiber and also in the lumen of the fiber. And then we have the bound water zone. Finally, about 9% moisture, whatever residual water left is tightly held by various physico-chemical processes, and evaporation is more difficult rate is further reduced. Okay, this is where the evaporation rate is the lowest. Okay, if you can recall back what I have taught before, so basically the moisture content of the pepper, the targeted moisture content of about 6 to 8%. Okay, so the bound water so basically what remains in the pepper, so we are talking about the bound water. So finally, at about 9% moisture content, whatever residual water left is tightly held by various physicochemical. As we remove more water, so basically the water left inside the fiber has a very strong hydrogen bond with the fiber itself. That's what we call the bound water. They have the physical bonding. So this is what we call the bound water zone. Okay, that's all for the different phases. If you are talking about different phase of drying, we are talking about phase on each drying cylinder. We are talking about zone, we are talking about maybe different zone requires, like this one, warm-up zone, we have about 5 cylinders. And then we are talking about the constant rate zone, falling rate zone, and finally, at the end of the drying section, we will have the bound water zone. This is where we reach the targeted moisture content 6 to 8%. Okay, maybe there is no removal of water at all at the end stage of drying process. Okay. Sekarang pukul berapa? 10.48. Nak sambung lagi ke? Okay, I think that's all. I covers almost half of the slides. Okay. So, the rest we will cover in the next class lah. Okay. So, I think that's all for today's class. I stopped sharing the slide, the screen. So I hope you guys captures what I have lectures to you all. So basically the drying process is very easy. You need to remember what are the objective of the drying process. Drying process to evaporate and then to evenly evaporate. And then what is the phases involved in the cylinder? We have 4 different phases. And then we have 4 different zones. So if the question asks you, identify 4 zones in the drying process. So don't, you jangan salah jawab pula, you letak yang 4 phases tu. Okay, phases and zone is totally different thing. Okay, so each of the cylinder have 4 different phases. And then during, for the whole drying processes or for the whole drying process, so basically we have 4 different zones. So I think that's all for today. So next week we will have a class from 12 to 1. So I will cover the rest for the drawing sessions. So I hope I will upload the slide for the drawing session after we completed the drawing lectures. So I think that's all. Thank you, class. If you have any question, maybe you can text me or maybe you can come to my office to discuss about the topic, about the pressing, drying, and anything related to my lecture. So I think thank you. That's all. Thank you, class. Okay, bye-bye.